This is Professor Pelton. This is part 4 of the chapter 5, section 6. Okay, so this is the last student problem you had to do. So notice in this case, it's already pre-factored to save us some time. So I have to go through and do the PQ list and all that. So if you multiply it all out, which is not necessary, because what you notice right off the bat is 2 of these cancel, or one set cancels. So I get x minus 2 and x plus 1 over the x plus 2. Okay, so originally the problem would have been a cubic over a quartic, right? So essentially the original y equals would have been x cubed over x squared, right? Before I canceled. And there's some terms afterwards, so it's really irrelevant. So if the numerator is bigger than the denominator, that tells us right away there's a slant. And you can prove that to yourself by plugging in the infinities, right? So infinity over 3 over infinity squared. So that's going to give you infinity over 1, which is infinities, which means there's no horizontal asymptote, right? So you have to do long division to figure out the slant. Okay, so x plus 2. And if I multiply this out, which I'm going to have to do now, is going to be, let's see, x squared minus 2x plus 1x is minus 1x plus 2, no, minus 2, sorry, because it's negative 2 times 1, it's negative 2 over x plus 2. Okay, so x squared minus 1x plus 2. All right, so I times it by x. X times x is x squared. X times 2 is 2x. Okay, so we'll subtract. So I get negative 3x, bring down the 2. So I'm going to multiply it by negative 3. So that's negative 3x minus 6. So if I subtract, I'm going to get... oh, I put a positive 2. That's a minus 2. Sorry. That's a minus 2. Excuse me. So that's a minus 2. I was going to say I fixed it up there, but not down there. Okay, so that's going to give me a positive 4. So I'm left with plus 4 over x plus 2, which that remainder will not matter, because if you plug infinity into there, 4 over infinity is nothing. So essentially you're left with y equals x minus 3 as your slant asymptote, which means it has an intercept of 3, and it has a slope of 1 over 1. Right? So that is y equals x minus 3, slant asymptote line. Okay, so holes, we do have a hole because one of the things canceled, right? So it's 3 comma something, because the x minus 3, right, canceled out, right? Take something out, you're left with a hole. Okay, so if I plug that value in, I'm going to get y equals 3 minus 2 over 3 plus 1 over 3 plus 2. So I'm going to use the factored form because I think that's the easiest way to get it. So I'm left with what? 1 times 4 over 5, right? So 4/5. So 3 and 4/5, we're left with a hole. So I'm going to go over to 3, 1, 2, 3, and 4/5, we're going to put a hole. Okay, so vertical asymptotes. Clearly we have one of those because this cannot equal 0. So x is equal to negative 2. All right, so we're going to put the vertical asymptote in there. X is equal to negative 2. Okay, so intercepts, if we plug in 0 for x, okay, so if I plug in 0 for x, I get y equals 0 minus 2 over 0 plus 1. And then 0 plus 2. Okay, so that's going to give me negative 2 over 2. Essentially, that's negative 1, right? I always like using the factored form for a lot of these because it's easier to figure out. So 0, negative 1 is the y-intercept. Okay, so for the x-intercept, it's where the numerator is equal to 0, right? So it's equal to 0. So where is this equal to 0? Okay, well that's at 2, 0 and at negative 1, 0, correct? So 2, 0 and negative 1, 0. Okay, and that's actually all we need to make the graph, because essentially it's going to follow the vertical asymptote, go through the intercepts, and it's going to then follow the slant asymptote. So down here, it's either going to be up here or it's going to be down here. Well, I'm telling you right now, you can plug a value into the original function to figure it out, but it can't be the top, because if it's the top, it's going to have to go through the x-axis. But we didn't find any additional x-intercepts, so it can't be the one up top. It has to be down bottom. And in fact, if you plug in a value that's negative, you'll find pretty simply that 3 negatives over 2 negatives gives you a negative outcome. So essentially, the graph is going to have to follow the asymptotes down below. Okay, so the last thing we have to think about is, what if you have multiplicity? Okay, what is that going to do for the graph? Well, that's going to really, because you can cross the slant and horizontal asymptotes, because the slant and horizontal asymptotes have been crossed by most of our functions, right? But you can't cross the vertical ones, the vertical asymptotes. So the question is, when you do cross the axes, the x-axes, what happens? Well, we've already discussed that in a prior section with polynomials, based on odds and evens, how many times it repeats multiplicity-wise. Okay, so let's try this function here. So I've already done these in pre-factored form. I've already done the factoring for us to save us the time. So if I went through and multiplied this all out, first off, there's nothing in a common top and bottom, so there are no holes. Okay? And if I multiply this all out, this is x to the third over x to the third plus dot 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 plus dot dot dot. We don't care what the rest of it is if we actually spent the time to multiply it all out. What's important is this is 1 times infinity to the third over 1 times infinity to the third when I plug in the infinity. So that gives me 1, right? Or 1 over 1 for 1 when I cancel the infinities. So I have a horizontal asymptote, which means I do not have a slant one, correct? So I'm going to go to 1 and put that in there. Okay, so when this is not equal to 0, right, that can't be equal to 0. It's a vertical asymptote, correct? So that means at x is equal to -3 and x is equal to 2, we have vertical asymptotes, right? So -3 and 2. Okay, so these are our boundaries we have to work with. So now we just need our intercepts. So if I'm an y-intercept, then the x is 0, right? So if I plug that in, I'm going to get y equals 0 plus 1 squared, 0 minus 3. Oop, lost the squared. Come on. All right, on the bottom, 0 plus 3 squared, and then 0 minus 2. So I'm going to get 1 times -3, right? And then 9 times -2, correct? So that's 3 over 18, so 1/6. All right, so 0, 1/6, I have a coordinate. All right, so my x-intercepts is when the numerator is equal to 0, right? Because this is a y equals equation, correct? So if the numerator equals 0, the whole thing equals 0. So at x equals -1 and at x equals 3, we have x-intercepts as a result. So at -1, I'm sorry, and +3. Okay, so what I can tell you right now in the left-hand section, it has to be up here. Because 1, it doesn't cross the x-axis, so it cannot be down here. And if you plug a value in to the numerator, you're going to get a negative over a negative, which is a positive, so it makes sense. Okay, so the next one is going to come down to this point and bounce off. Well, how do I know it bounces off? Well, if this one happens twice, an even number of times, so it's going to then follow vertical asymptote there. Okay, this one is going to come up and it's going to cross the graph. Why this wouldn't cross the graph? Because this is the first power. That's an odd number of times. All right, pause the video. Try the student problem for yourself. Okay, so looking at this problem, I can tell right away that this is going to be a horizontal asymptote, because if I multiply the top, I'm going to get x to the third plus some terms. And on the bottom, I'm going to get 2x to the third plus some other terms, which are irrelevant, right? So if I try to do the slant asymptote, I'm going to get infinity to the third. We'll put a 1 in front. And then 2 times infinity to the third. So essentially, I get 1/2 is my horizontal asymptote. Okay, so we'll go to 1/2, and we'll put a dotted line. Okay, so y equals 1/2. Okay, so that means there's no slant because there'll only be one or the other. If I look at the factors top and bottom, it appears that nothing cancels. That means there's no holes. The denominator cannot equal 0, so that happens at 1 and 3. So x is equal to 1 and x is equal to 3 are the vertical asymptotes. Okay, let's see. So y-intercept is when I plug in 0 for x, right? So y equals 0 plus 2 squared, 0 minus 2, and then 0 minus 1 squared. I'm going to put the 2 in front, I forgot that. And then 0 minus 3. Okay, so we have 4 times negative 2. Come on. Four times negative 2. And on the bottom, we have 2 times 1, because that's a squared, right? And then a negative 3. So the negatives cancel and the 2's cancel and leave us with 4/3. Okay, so we'll go to 4/3, yep. All right, so that's basically 1 1/3, so 1 1/3, it's like right there. That's good enough. Okay, so for x-intercepts, that's when the numerator is equal to 0, because there's a y equals, right? So when the top equals 0, the whole thing equals 0. So then we have 2, 0, and negative 2, 0 as our coordinates. So 2, 0, and negative 2, 0. Okay, so on the left-hand side, it's clear we're going to follow the vertical asymptote. It's going to come down to this coordinate here, bounce off, and then follow the horizontal asymptote. And I know it bounces off because it happens twice, an even number of times. Okay. On this one here, it's going to follow the vertical asymptote. It's going to cross the point and follow the horizontal asymptote, or vertical asymptote again. That's because it happens once, which is an even number of times. And lastly, on the right-hand side, it's either on the top or it's on the bottom. Well, I know it has to be on the top for 2 reasons. One, I can plug in a value. So I plug in a value, I get a positive over a positive, which is going to be a positive answer. Plus, there's no x-intercepts down below. That what we found, so it couldn't have crossed the axes anyway, so therefore it has to be on the top. Okay, that is the end of part 4.